The use of aluminum conductors for 15, 20, and 30 amp branch circuits in residences has been a subject of discussion for many years. Back in 1972, the National Electrical Code, NEC, prohibited the use of aluminum conductors for these circuits. This was primarily due to concerns about aluminum's susceptibility to creep, which is the gradual deformation under stress, and its tendency to oxidize. Oxidation can increase resistance and create unsafe conditions. More recently, specifically in the 2020 NEC, these restrictions have been relaxed for certain types of aluminum conductors. Article 250.140d now permits the use of copper-clad aluminum conductors, often referred to as CCA, for branch circuits rated up to 30 amps. So, what exactly are copper-clad aluminum conductors? They are made by cladding pure aluminum with a thin layer of copper. This copper cladding serves as a protective barrier, shielding the aluminum from oxidation and mitigating creep. This makes CCA a more suitable option for electrical wiring. To understand the evolution of these regulations, let's look at the code sections that originally outlawed the use of aluminum conductors for 15, 20, and 30 amp branch circuits. Firstly, in the 1972 NEC Section 250-118 address this. Secondly, the 1975 NEC Section 310-15 b continued to restrict its use. Thirdly, the 1981 NEC Section 310-15 b2 further clarified these restrictions. As of the 2020 NEC, CCA are now acceptable for branch circuits rated up to 30 amps. However, it's essential to keep in mind that some local building codes may still maintain restrictions on the use of aluminum conductors. It's always best practice to consult with local authorities and adhere to all applicable code requirements in your specific area. In summary, the NEC stance on aluminum conductors in residential branch circuits has evolved. While early editions prohibited their use due to concerns about creep and oxidation, the 2020 NEC now permits copper-clad aluminum conductors for circuits up to 30 amps, provided they meet specific requirements. Always verify local codes for any additional restrictions. The primary concern with aluminum wiring stemmed from its properties compared to copper. Aluminum is more susceptible to expansion and contraction with temperature changes. This difference in thermal expansion rates between aluminum and the materials used in electrical connections could lead to loosening of connections over time. Loose connections increase electrical resistance, which generates heat. This heat, in turn, exacerbates the expansion and contraction cycle, eventually leading to overheating, arcing, and potentially electrical fires. Secondly, aluminum oxidizes readily when exposed to air, forming a layer of aluminum oxide on its surface. Aluminum oxide is a poor conductor of electricity. This oxide layer can increase resistance at connections, again leading to heat buildup and potential fire hazards. Standard electrical connectors and devices are typically designed and tested for use with copper conductors. The use of these devices with aluminum conductors can lead to corrosion due to galvanic reactions between the dissimilar metals, further compromising the integrity of the connection. The older aluminum alloys used in wiring were more prone to creep, which is the slow deformation of a material under constant stress. This creep can cause connections to loosen over time, leading to the same problems of increased resistance, heat generation, and fire risk. The introduction of copper-clad aluminum conductors and the relaxation of restrictions in the 2020 NEC are based on improvements in conductor technology and connection methods. Copper-clad aluminum conductors combine the conductivity of aluminum with the corrosion resistance and improved connection properties of copper. The copper cladding protects the aluminum core from oxidation, ensuring a more stable and reliable electrical connection. Manufacturers have also developed specialized connectors and devices designed specifically for use with aluminum conductors. These connectors are typically made of materials that are compatible with aluminum and feature designs that maintain a tight and secure connection over time. These include the use of antioxidant compounds that prevent oxidation at the connection point. The NEC sets forth specific requirements for the installation and termination of aluminum conductors. These requirements include the use of approved connectors, proper wire sizing, and the application of antioxidant compounds to prevent corrosion. Adherence to these requirements is crucial for ensuring the safety and reliability of aluminum wiring systems. Aluminum conductors typically have a higher resistance than copper conductors of the same gauge. This means that aluminum conductors must be larger than copper conductors to carry the same amount of current without overheating. The NEC specifies ampacity ratings for different types of conductors, and it's important to select the correct wire size based on the circuit's ampacity and the type of conductor being used. Aluminum conductors are more sensitive to damage from overbending or nicking than copper conductors. Care must be taken during installation to avoid damaging the conductor insulation or creating stress points that could lead to failure. Proper stripping techniques and the use of specialized tools are essential for ensuring a safe and reliable connection. The NEC provides detailed guidelines for the installation and termination of conductors. These guidelines cover topics such as wire bending space, terminal torque requirements, and the use of approved connectors. Compliance with these guidelines is essential for ensuring the safety and reliability of electrical wiring systems. When working with aluminum conductors, it's important to use connectors that are specifically listed and labeled for use with aluminum conductors. These connectors are designed to accommodate the unique properties of aluminum and maintain a tight and reliable connection over time. The NEC requires that all electrical connections be made in an approved manner. This means that connections must be mechanically sound, electrically continuous, and properly insulated. The use of wire nuts, terminal strips, and other approved connectors is essential for ensuring safe and reliable connections. Antioxidant compounds are specially formulated greases that prevent oxidation at electrical connections. These compounds are typically applied to the conductor before the connection is made and help to ensure a long-lasting and reliable connection. The NEC requires that antioxidant compounds be used with aluminum conductors in certain applications. Proper torque is essential for ensuring a tight and secure electrical connection. Over-torquing can damage the connector or conductor, while under-torquing can lead to loose connections and overheating. The NEC specifies torque requirements for different types of connectors, and it's important to use a calibrated torque wrench to ensure that connections are properly tightened. Electrical connections should be inspected periodically to ensure that they are still tight and in good condition. Loose connections should be tightened, and corroded or damaged connectors should be replaced. Regular maintenance is essential for ensuring the safety and reliability of electrical wiring systems. When replacing existing wiring, it's important to carefully consider the existing wiring system and the load that it serves. If the existing wiring is undersized or in poor condition, it should be replaced with a larger gauge wire or new wiring system. The NEC provides guidance on the proper sizing of electrical wiring systems. The NEC also specifies requirements for the protection of electrical circuits from overcurrent. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. Proper overcurrent protection is essential for preventing electrical fires and protecting electrical equipment. Grounding is an essential safety feature of electrical wiring systems. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. The NEC specifies requirements for grounding electrical systems and equipment. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding is essential for preventing electrical shock and ensuring the proper operation of overcurrent protection devices. The NEC specifies requirements for bonding electrical systems and equipment. Electrical work should only be performed by qualified electricians who are trained in the safe installation and maintenance of electrical systems. Electrical work can be dangerous, and it's important to take precautions to avoid electrical shock and other hazards. Before working on any electrical circuit, it's important to turn off the power at the circuit breaker or fuse box. This will help to prevent electrical shock. When working on electrical circuits, it's important to use insulated tools. Insulated tools will help to protect you from electrical shock. When working on electrical circuits, it's important to wear safety glasses to protect your eyes from debris. When working on electrical circuits, it's important to follow all safety precautions. The NEC is a comprehensive set of standards for the safe installation and maintenance of electrical systems. The NEC is updated every 3 years, and it's important to stay up to date on the latest requirements. The NEC is adopted by most states and local jurisdictions in the United States. Local building codes may also have additional requirements for electrical installations. It's important to consult with local authorities to determine the applicable code requirements in your area. The use of aluminum conductors in residential branch circuits is a complex topic with a long history. The NEC regulations have evolved over time to address concerns about safety and reliability. By understanding the history of these regulations, the properties of aluminum conductors, and the proper installation techniques, you can ensure the safe and reliable use of aluminum conductors in your home. Always consult with a qualified electrician and follow all applicable code requirements. The ampacity of a conductor is the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, material, insulation type, and the ambient temperature. The NEC provides ampacity tables that list the ampacity of various types of conductors under different conditions. The voltage drop in a conductor is the decrease in voltage from the source to the load. Voltage drop is caused by the resistance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to run slower, and other electrical equipment to malfunction. The NEC provides guidelines for limiting voltage drop in electrical circuits. The short circuit current rating of a conductor is the maximum amount of current that a conductor can safely withstand during a short circuit. The short circuit current rating of a conductor is determined by its size and material. The NEC requires that conductors be protected by overcurrent protection devices with a short circuit current rating that is equal to or greater than the short circuit current rating of the conductor. The ground fault current is the current that flows through the grounding system during a ground fault. The ground fault occurs when a live conductor comes into contact with a grounded surface. Ground fault current can be dangerous, and it's important to protect electrical systems from ground faults. The NEC requires that electrical systems be protected by ground fault circuit interrupters, also known as GFCIs, in certain locations. Electrical noise is unwanted electrical signals that can interfere with the operation of electronic equipment. Electrical noise can be caused by a variety of sources, including electrical motors, fluorescent lights, and radio transmitters. The NEC provides guidelines for reducing electrical noise in electrical systems. Harmonics are unwanted electrical signals that are multiples of the fundamental frequency of the power system. Harmonics can be caused by a variety of sources, including electronic power supplies, variable speed drives, and arc furnaces. Harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with electronic equipment. The NEC provides guidelines for reducing harmonics in electrical systems. Surge protection is the protection of electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Voltage surges can damage or destroy electrical equipment. The NEC requires that surge protection be provided in certain locations. Energy efficiency is the use of less energy to perform the same task. Energy efficiency can save money on utility bills and reduce greenhouse gas emissions. The NEC provides guidelines for improving the energy efficiency of electrical systems. Renewable energy is energy that comes from sources that are naturally replenished, such as solar, wind, and hydropower. Renewable energy can reduce reliance on fossil fuels and reduce greenhouse gas emissions. The NEC provides guidelines for the installation of renewable energy systems. Smart grids are electrical grids that use technology to improve the efficiency, reliability, and security of the power system. Smart grids can enable the integration of renewable energy sources, improve grid stability, and reduce energy consumption. The NEC provides guidelines for the installation of smart grid technologies. Electrical safety is the practice of working with electricity safely. Electrical safety is essential for preventing electrical shock, fires, and other hazards. The NEC provides guidelines for electrical safety. The principles and practices outlined in the NEC aim to minimize risks associated with electricity, ensuring the safety of people and property. Continuous learning and adherence to the latest code requirements are crucial for all electrical professionals.